Hi there. Well, what we're going to look at is sections 10.3 and 10.4, which is mainly just simplifying radicals and reducing the radicals and what's inside. And we'll also be multiplying and dividing. That's more the 10.4. So when we start to, let's say, okay, multiply. Looking up here, if you multiply these together, and this is the key, and this will address this in 10.5, is the indexes, or the indices here, they need to be the same in order for you to multiply what's inside. So again, just be aware of that. In these two sections, these will be the same. And in 10.5, we'll learn how to simplify radicals where the index is not equal to each other. All right, so let's go ahead and we're going to get started. This isn't really too bad, other than you just have to learn to take out according to the index, you know, whether or not it's a 2, is it a square root? You take out 2 of something, a cube root, a fourth root tells you how many of something you need in order to pull it out of the radical itself. So before we do that, I just kind of wanted to review a little bit and on how to reduce radicals. So in other words, if I were to have the square root of 50, all right, that froze. Wow, that was delayed. I hope it doesn't keep doing that. But if I have the square root of 50, in order to reduce this, we're going to be using tree diagrams. And again, you're looking for 2 of something because it's a square root. So here, in this case, is the light on? There, maybe, I don't know if that will help or not. So you make a tree diagram and you start with 2 numbers multiplied together that give you 50. And you don't have to break it down into primes. As soon as you see 2 of something, you can take it out. And sometimes you do end up taking it down into primes, and we'll do an example of that. So 50, let's say maybe you said 5 times 10. Okay, that's you know, gives you 50. Now again, I don't recognize 2 of something, so I'm going to go ahead and I'm going to keep breaking this down. All right, so I broke the 10 down and I broke the 50 down. I cross them off when I break them down, so I don't try to include that 10 in the answer. So if you look here, I want a square root, and again, if there's nothing there, it's a 2, and I want 2 of something. And looking here, I have 2 5s. So the 2 5s are going to come outside of the radical. So I'm going to write this here. Okay, that's part of our answer. These 2 will come out as a 5. But the 2, there's only one of the 2s, and so it stays inside. And there's your answer. Okay, let's look at another one. Let's look at maybe the cube root of 24. All right, how would we do the cube root? Is there 3 of anything inside the 24? So we'll use a tree diagram. And sometimes these numbers can get kind of large, but you've got your calculator and that would help break it down. But we're going to say 8 times 3 is 24. So then we're going to keep looking. We have 4 times 2. Okay, that breaks down the 8. Then we'll break down the 4 into 2 times 2. So we did end up going down all the way to the primes. And if you'll notice here, we've got 3 2s here. Now, and we only have 1 of the 3s. So these 3 2s, because I wanted 3 of them, that was my index, that's my gatekeeper, I want 3 of something in order to pull it out. So I've got these 3 2s, so I'm going to write my radical. So outside, the 2s are going to come outside of my cube root. But the 3 stays inside because I only have 1 of them. So don't make this harder than it is. You know, probably maybe one of the harder things is breaking it down into the primes. But once you have it down into some primes, or even, you know, sometimes you'll have 2 4s and you know, okay, I've got the 2 4s. I don't need to break the 4s down. You already recognize that you have 2 of something. But this is kind of what we're going to be practicing today. Now, the other one is dealing with exponents. All right, so let's do a couple of examples of exponents. This is just kind of an introduction, and then we'll go through the notes. I think this might help. But again, if I have the square root of x squared, all right, now it's a square root, so I'm looking for 2 of something. And if you look here, this means x times x. X times x gives you x squared. So I have 2 of them. So they will come out of the radical. I'm just going to write a radical right here. These are going to come out of the radical, but there's nothing left inside. Since there's nothing left inside, it's just x. All right, everything came out. Okay, because you were looking for 2 of something and you had 2. Remember that when you're breaking these down, when you do break them down, you add exponents to go back to the original. So, we're not multiplying those, we're adding those to go back to the original. Well, that one was kind of, say, well, I can see that. Or if I had the cube root of x cubed, okay, I've got 3 x's here. This is x times x times x. So they come out and nothing's left. So your answer is x. And again, it depends on the instructions. On this one, you may have to have absolute values around it, going back to this one right here, because remember, this is the principal square root. It's got to be positive. If it's a cube root, it can be positive or negative, so you don't need the absolute values. And they may say, assume that all the substitutions are positive integers, so you don't have to worry about the absolute values. But, all right, so, sorry, I don't want this to be too long. Let's go ahead, and I'm going to look at the square root of x to the 7th. Okay, what are some strategies we can do to see, groups of what? Now, I want 2 groups. Okay, this is 2. So what I'm going to do is I'm going to take 7 divided by 2, and this is just one strategy. 7 divided by 2 gives me 3, that would be 6, with the remainder of 1. Okay, so 2 goes into 7 3 times, that gives me 6, with the remainder of 1. So this right here means I have 2 of those. Okay, I have 2 x cubes. And I'm going to have 1 x to the 1st. Okay, I'm going to have an x to the 1st here. So what I'm finding when I do this division are the exponents I'm going to be using as I break that x to the 7th down. And we'll try another one. Now, again, I was looking for 2 of something, and I have 2 x cubes. So they are going to come out, and that x to the 1st stays inside. So this kind of helps you know what exponents to use as you break it down. Now, another way of writing this, especially if you had like a 5th root, you may not want to write something down 5 times. You can use, this is x cubed to the 2nd. Okay, that gives you you have 2 of those. So write that using exponents. I have 2 of these, and then, but for the most part, for you guys, you could just write it out if you need to. All right, and then, add the exponents and check. 3 plus 3 is 6, plus 1 is 7. So it goes back to the original. Let's just try one more, and then we'll get started on some more examples. We'll be done with our introduction. It's almost an entire lesson itself. So let's go ahead and do, let's do the 4th root of x to the, let's do the 10th. Okay, we want the 4th root of x to the 10th. Now, I'm going to use division here. I'm going to take 10 divided by 4. And it goes twice, that's 8, with a remainder of 2. So in other words, 4 into 10, it goes twice, that's where this came from, and it has a remainder of 2. So this tells me my exponent, so I've got x squared times x squared times x squared times, I have 4 of them, I have 4 of those groups, and then I have a remainder of an x squared. maybe this probably wasn't the best example, too many x squareds. But anyways, I've got the fourth root of all of these squareds here. And I came up with these exponents with the division. This one came with the 4, and this one was this last one. So I need groups of 4. Well, 1, 2, 3, I have 4 of those. And those x's need to stay inside. Okay? All right. Well, we have lots of practice here, but that just kind of introduces it. Okay, now let's go ahead and let's look at multiply or divide. And again, we're going to be reducing using what we learned in the introduction if we need to. Now, when you multiply these together, because they have the index is the same on both of these, they're both a 2, you can go ahead and multiply what's inside. If I had numbers out in front, I would multiply the numbers out in front together. But here, we're going to multiply these. And what I like to do is I like to keep them separate for just a minute and then ask myself, okay, can that be reduced? Do I have 2 of anything? So I'm not going to get a 15 and then break it down again. I'm just going to keep it like this. And then once I've decided that I only have 1 5 and 1 3, you multiply them together. And there's your reduced answer. I've got 1 3 and 1 5. Okay. All right. Let's multiply the next ones together. On B, well, when you multiply, okay, they both have the same index. It's both a 2. So we're going to go ahead and we're going to multiply what the radicands together using the proper definition here. So when I do that, you'll need to use parentheses. X plus 3 times x minus 3. Now, to finish this up, you would just use the FOIL method. Now, okay, you need to ask yourself, do I have 2 of the x plus 3s? No, I've only got 1 of those groups. I've only got 1 group of x minus 3. Now, if I would have had 2 groups of x plus 3, the x plus 3 could have come out, but I've only got the 1 group. So here, neither one of these are going to be able to come out. So you would just multiply them together using the FOIL method. X times x is x squared. 3x and a negative 3x is 0 minus 9. My radical sign is a bit long. That cannot be simplified. You cannot simplify the x squared and then simplify the 9 separately. So when you've got a plus or minus sign, either the entire group goes or nothing goes. So I don't have 2 of these x squared minus 9s. I do not have another x squared minus 9. If I did, x squared minus 9 could come out, but I've only got 1 of those groups. So it stays as x squared minus 9. So you'll have to have 2 of them, 2 of those groups in order to pull it out. So that is actually your answer. And the temptation, again, is to simplify the x squared, get an x, simplify the 9, get a 3, but avoid that temptation, all right? When you've got plus or minus signs, the groups have to be exactly the same. Okay, let's go on to C. Again, the index here is 3, and the index here is 3. So because they are the same, I can go ahead and multiply the radicands together. So I end up with 4 times 5. So I'll multiply those. You'll now need to look to see, do I have 3 of anything in here? Do I have 3? And you've got 2 2s here, but not 3 of them. So there's nothing you can do to reduce, which means we would just have the cube root of 20 as your answer. All right. So again, you know, as long as this index and these 2 indices, these 2 indexes are the same, then you can multiply the radicands together. Otherwise, they have to stay separate. and we'll deal with that in chapter or our next section. Now that kind of explains a little bit of multiplication. Let's look at the division. All right, the division. Let's look at this up here. Now, what they're saying in this definition is that if they are under the same radical with this index, you can handle them separately. Also, you can reduce them separately. Also, you can go this here and put them under the same. So again, you can go back and forth this way. And that's what we're going to practice is sometimes you'll need to go from here to here in order to reduce. And sometimes if you can't reduce, you separate them and reduce looking for the nth root, whether or not it's you need 2 of something to come out or 3 of something to come out, and reduce them separately. Okay, now let's go through our steps. On this one, what you need to ask yourself is underneath here, can I reduce 27 over 125? So when you're given a fraction, reduce it first if you can. It makes it so much easier. Well, you cannot reduce a 27 on a 125. There's nothing that goes into them that's in common. So I'm going to use that definition. In order to simplify this, I am going to separate them, and I will look for 3 of anything in both of those numbers. Let's talk about the 27. Is there 3 of anything in a 27? Well, we've kind of looked at 27 before. 27 is 3 times 3 is 9 times 3 is 27. So 27 is 3 times 3 times 3, and I think I can squeeze that in, which gives you a 3. So those come out, and nothing is left inside. Okay. But what about the 125? And again, you know, you'll work with these a lot, so I'm hoping that you kind of remember that there are actually 3 5s in 125. So this right here, the cube root of 125 is 5 times 5 times 5. Okay, you can just kind of break it down using a tree diagram. It ends in 5, so 5 times 25. If you need to, you can use those tree diagrams. But I've got 3 of these 5s. I need 3. They'll all come out. Nothing is left inside. There's your answer, 3/5. Okay. Let's look at the next one. E, division. First off, can I reduce 25 over y squared? Can that be reduced? And it cannot. So what we're going to do is we're going to separate them into 2. We're going to take the square root of 25 over the square root of y squared. So again, this is a square root. So I'm going to see if I can reduce the square root of 25. And the square root of 25 is 5. And the square root of y squared means I've got 2 of these y's is y. And I don't think that you'll have to use absolute values. You know, they'll probably tell you if you need to. So then there would be the answer. Okay, 5 over y. Y cannot be 0. Can't have a 0 in the denominator, but that's okay. All righty, let's look at the next one. Right here, okay, we're going to multiply and divide, but before you start, you can see if you can I reduce this way? Can I reduce here? One way, because it is the 4th root, you could do that and then see if anything in the numerator would reduce with anything in the denominator. And in this case, nothing will. So 7 and y will not reduce with a 5 or an x. So you can, you can go from here and you can put them underneath the same radical and then try to reduce it. Well, since they don't reduce, I'm going to multiply across. So I'm going to end up with the 4th root of 7y kind of doing two things at once here, but I think you guys can. So I separate. You multiply across, and I separated them out, and you end up with the fourth root of 7y over the fourth root of 5x. Nothing will simplify. So for right now, we're going to leave it like that. Now we're going to be doing something later in this this section, in section 3, where we'll kind of talk about that. But that's as far as you could go. Now you could also have written it like this. To tell you the truth, I don't know which way my math lab will accept. Neither one of these are incorrect. Probably this one right there. And it cannot be reduced. Now this last box down here, it just kind of went over what we talked about with that B, and that's this right here. You know, make sure you don't make that mistake. So that's a does not equal x minus 3. These cannot be separated from each other. They go together or they don't go at all. You would have to have had 2 of the x squared minus 9s in order to pull it out. And then also, again, this is going to be 10.5, where if you look at the index here is 3 and the index here is 4, you cannot multiply those like this. So again, you just kind of be aware of that. Okay? And we will talk about that later. But for right now, the index will be the same on both of them. All right, let's go ahead and reduce. Let's practice reducing some numbers with some variables. And then I think we'll look at some division. Okay, let's start. 200. You need 2 numbers multiplied together to give you 200. This is a square root, so we're looking for 2 of things. Let's go 2 times 100. Okay. You could have used 20 times 10. It doesn't matter how you start. Just be aware you're looking for 2 of something. Now when you get to this 100 is 10 times 10. I can stop there. I don't have to do the 5 and the 2 and the 5 and the 2. But we're going to, I want to explain to you what you do with the 5 and the 2 when you have like 2 5s and 2 2s, what you do with those. But we do know that we're going to have a 10 square roots of 2. But let's go ahead and keep breaking it down. I'll kind of explain my last statement there, what I meant by that. All right, okay, we do know that the answer is 10 square roots of 2, just from this last section here. I had 2 10s, they come out, that 2 stays. But if you didn't and you broke it down further, I have 2 5s. So the 2 5s will come out. I have 2 2s. Whether or not you use these 2 or these 2, it doesn't matter. I have 2 2s. And whatever comes out of your radical, you multiply together. So this becomes 5 times 2, and this is a 2. So when you bring things out, you know, I brought the 2s out and the 5s, you multiply them together as they come out. Okay. Either way, you'll get 10 square roots of 2. Perfect. Let's try 80. Square root of 80. Let's break it down. 8 times 10. Okay. I don't see 2 of anything. Let's go with 2 times 4, 2 times 5. Oh, wow. I've got the 2 2s. Okay. And let's go ahead and do the 4. So I broke the 4 down, the 8 down, and the 10 down. Those have been broken down. And I'm looking, it's a square root, so I'm looking for 2 of something. Well, I have 2 2s right here, and I have 2 2s right here. So this group is going to come out of the radical. This group is going to come out of the radical, and you multiply them as they come out, and the 5 is going to stay. So we end up with 4 square roots of 5. All righty, And you could break it down differently. You know, you could have done 16 times 5 is 80. And then the square root of 16 is 4. But, you know, either way, you'll end up with the same answer ultimately. Okay. All right. Let's look at C. Oh, 18 is not bad to break down, but okay, this is all multiplication, so you can do them separately. So if they're all multiplication, you can do them separately. But if I add in a square root of, let's say, x plus 3 or x squared plus 3, there's nothing you can do. If I had x squared plus 3 squared, which means I have 2 of those x squared plus 3s, then it will come out. You don't need absolute values because the x is squared. Okay? Otherwise, it cannot. You're done unless you have 2 of them, and then they can come out as a group. But here, if you notice, there's no plus or subtraction symbols. So that means I'm going to do these each individually, whereas here you cannot do them individually. So 18, let's deal with our 18 here. Let's break it down into 9 times 2 or 6 times 3, you know, whatever you want to do. So let's do 9 times 2. And the 3 and 9 is 3 times 3. And again, we're still in the square roots. We're still looking for 2 of something. So looking at this 18, I'm going to put we may not have anything inside. Everything may come out, but we'll just go ahead and put the radical there. These 3's come out. Okay, the 3's come out because I have 2 of them. So it's outside. The 2 has to stay inside. So we've done the 18. We broke it down. We have a 3 square roots of 2. Now let's look at our variables. Our variables, I have 2 of the x's. So if you have 2 of those and we're looking for 2, they'll come out as an x to the first. Okay? X to the first. And the y, I've only got 1 y. Just like I only had 1, 2, I've only got 1 y, so it stays inside. And there's your answer. Now you may have to, depending upon what they want, you may have to put absolute values around this x because it came out as an odd powered, but otherwise just leave it. So there's our answer. The 3's came out, the x's came out, but the 2 and the y had to stay. All right, let's look at D. First off, is it possible? You know, whenever you see a negative, you have to ask yourself, well, since it has an odd index, then yes, it is possible. You can have a negative, and the negative just is going to be a part of your answer. So we know our answer will be negative. But let's just go ahead and break it down, and then we'll deal with the negative when we're done breaking this down. 72. Well, 72 is we have 9 times 8, 3 times 3, 4 times 2, 2 times 2. So I broke the 72 down. I've got a couple 3's and I've got 3 2's. And so we're looking for 3 of anything. So, you know, kind of be aware, you kind of get used to just looking for 2, but pay attention to your index and how many you want. So the 3's, I've only got 2 of them. So I know that both of those 3's have to stay, and you multiply them back. You just kind of multiply them back. But here, I'm going to go ahead and do my radical. I have 3 of the 2's. So they're going to come out, and bring the negative out with them. You know, put your negative in the front. Don't leave it inside. Bring it out. So this came from the fact that I had these 3 2's. And then I have the 2 of these, not enough, so they have to stay. And so just multiply them back together. So your answer is a -2 cube root of 9. So when you're typing it into my math lab, you guys, make sure that you put that cube root there. You know, don't write, because you know you may have everything right, but not that. So, okay. All righty. Let's look at this next one. So again, a fourth root now, so we need 4 of something. So 162, wow, we've got to come up with, we're going to break this 162 down. I'm going to come over here. It's a little bit long. So I've got 162. I'm going to break it down. Well, I know 2 goes into it because it's even. So 2 would be 81. Ooh. And 81 is 9 times 9. We're looking for 4 of something. The 9 is 3 times 3, 3 times 3. So I broke the 9s down and the 81s down. Okay, 4 of something. Looks like we have 4 3s, but that 2 is only one of them. It's got to stay inside the radical. So again, we've got part of our answer. We'll just write it here. Put that 4th root. Don't forget it's the 4th root. And then I've got 4 of those. So that whole group is going to come out. We have the 3. And that 2 is going to stay inside. So we've taken care of the 162. Now we'll take care of the x to the 6th. All right, x to the 6th. Well, let's go ahead and let's do our little division thing here. Let's take 6 divided by 4. 6 divided by 4, let's see, 4 goes into 6 once. And you'll have a remainder of 2 when you do that, okay? 6 goes into 4 once. Or excuse me, 4 goes into 6 once. With a remainder of 2. Those are going to be your exponents on your x. So in other words, I've got 4x to the firsts. So I'm just going to rewrite this inside right now. I've got 4x to the first. And I have 4 of those groups. Division puts things into groups. I have 4 to the first power. And I have 1 of them to the second power. Okay. Is that right? Well, let's see. I know that when I multiply, all I did was I just broke down the x to the 6th. And let's see if that's right. I've got 1, 2, 3, 4, because you add those exponents, 4, 5, 6. So that does work. And we need 4 of something. So these are going to come out as an x to the first, but this x squared has to stay. This x squared needs to stay because there's only 2 x's in there. There's not enough. So here's your answer. And again, you may need absolute values. Whenever you take a variable out to an odd power, they may want you to have an absolute value around that, or they may just say the x's are all positives. So, all right. Okay. I'm hoping this makes sense, you know, and if you guys struggle with this, let me know. There are other methods, there are other ways, you know, we could look at that. This is just kind of maybe a guide to finding the exponents, the right exponents. So, okay. Let's look at this next one. Now we know that we cannot do these separately. So what we're going to do is we're going to have to factor it. Just like we factored the 162, we broke it down. We have to factor this one. It's just not quite as easy as factoring the numbers. So our steps for factoring: take out what's in common. So I'm going to take out a 3. Take out your greatest common factor. That's always the first step in factoring. I think I want to move this up a little bit. Okay. All right. So we took out that. So we've got x squared. Let's see, minus 2 gives you that, x, plus 1. Don't forget the plus 1. So if you need to, go ahead and multiply and make sure you come back to the original. Let's keep factoring. So we're going to see now, x times x gives you x squared. 1 times 1 gives you 1. And if they're both negative, they'll give you a positive 1 when you multiply, added together is a -2. So we have the square root, which means we were looking for 2 of something, and we've got it. So I actually do have, I'm going to rewrite it. I do have 2 of those. I have 2 of them. So they will come out, and you'll either, I'm going to write them with an absolute value when they come out. They need to be positive, and then we'll look at what if they're always, if they tell you in the instructions that you don't need to worry about absolute values. And the square root of 3 is on the inside. Left, the 3 stays. There's only 1 3. What are some other ways if they told you, well, this is always going to be positive or whatever? Chances are this is what they're going to want, but you could have had x minus 1. You can put that in front, you know, using parentheses. This would have also been, I would use absolute values. Okay, and you know, like I say, you don't have to put the square root of 3 can be behind or in front. It doesn't matter, because 2 times 3 is the same as 3 times 2. So your order in multiplication doesn't matter. Okay, but you do need the absolute, I would put the absolute values around that. Okay, meaning that it needs to be positive when it comes out. And if you don't, if they don't need that, if they tell you in the instructions, you have to have parentheses around it when it comes out. Okay. All righty. Let's go ahead and look at our next page, see how we're doing. We get to practice some more. Okay, let's look at this one. We're gonna practice some of the variables again. So we have an index of 2. So what we're going to do, the index is a 2. We're going to deal with the x's. We can do these separately because it's all multiplication, no plus or minus sign. So I'm going to start by taking, okay, I'm going to take 7 divided by 2. 7 divided by 2, it goes 3 times. Okay, that gives you a 6 with a remainder of 1. So 3 times with a remainder of 1. So what that tells us then is that we'll have x cubed. We're going to have 2 of them. Okay, you'll have 2 of those groups. And you're going to have an exponent of 1 left over. Okay, check it. All right, this gives you 6, 7. So there's that one right there. And looking, I'm going to put my answer over here. These are going to come out because I have 2 groups. But that x to the first has to stay inside. Let's do the y to the 11th. Let's take 11 divided by 2. Well, 11 divided by 2 goes 5 times. That leaves you 10 with the remainder of 1. So that tells you I have 2 x to the 5th. I have 2 x to the 5th, or y to the 5th, sorry. Y to the 5th times y to the 5th. I have 2 of those, x to the 5th, and I have 1 y to the 1st left over. That remainder is the exponent there. So like here I had 2 of the x cubes. I have 2 of the x to the 5th with the remainder of 1. Let's see, 5 plus 5 is 10, plus 1 is 11. So you did it right. Check it, just in case. I have 2 of these groups, and the y to the 1st stays inside. Wow. Let's try z. Doesn't look like I left enough room for that z, but if any of them come out. But let's z. Let's take 9 divided by 2. 9 divided by 2 is 4. Okay, that gives you 8, right? 2 times 4 is 8, but I still have a remainder of 1. This tells me I have 2 groups of 4 of x to the 4 of z to the 4th. Z to the 4th times z to the 4th, and I have 1 left over. Okay. And let's check it. Make sure we get 9. So we add these, add exponents when you're multiplying. Oh, why did I put a y there? I don't know, man. Okay, so we'll go ahead and add the exponents. That's 8, 9. So it works. So we have 2 of these groups. They're going to come out, and I'm going to have to copy it over because I did not leave enough room. The z to the 4th comes out, but that 1z is left inside. Okay, all right. So again, this is just one way. You know, there are other ways. You know, you can always Google it other ways if that doesn't make any sense to you. But okay, all right. Let's do another one, and then we'll work on some multiplying and dividing, and we'll see how that goes. And I think that it'll start to pick up. I wanted to make sure you know how to reduce radicals, though. Spend a little bit more time on it. Okay, a cube root. We have 16. Let's deal with the 16. We need 3 of something. Let's go with 4 times 4. I don't see 3 yet, so 2 times 2. So I broke it all the way down into primes. And look, I broke the 4s down across them all. I need 3 of something. So if you look here, I have 3 2s. So they're going to come out. But that 2 will be left inside. So maybe I'll just put my answer down here. It's a cube root. So I'm going to have a 2. And I'm going to leave some room for some variables to come out. And that 2 stays. So these came out, and that one stays. Let's go to 8 to the 7th. All right, let's take 7 divided by 3. It goes twice with a remainder of 1, because 3 times 2 is 6. So you have a remainder of 1. So this tells me I'm going to have 3 groups of x squareds. I'm going to have 3 groups of the x squareds. Again, we're looking for groups of 3. So this means I've got x squared, x squared, x squared. I have 3 groups of x squareds, and then 1 with a 1 there. So here I'm looking for groups of 3. Those will come out as an x squared. Oh, sorry, it's not an x, it's an a. Well, I think you guys have the idea, so I'm just going to change it to an a. I get so used to using x's all the time, so it's an a squared. And we have an a left over. You're just going to have to pretend those are a's, guys. Sorry about that. And we have an a to the 1st left over. Okay. Now, let's look at the b's. So we've got, let's take 14 divided by 3. Okay, 14 divided by 3, let's see, 12, so that would be 4, because that gives you 12 with a remainder of 2. So this tells me I have 3 groups of b to the 4th, so I didn't call it y. So b to the 4th, b to the 4th, b to the 4th, and I have 1b to the 2nd. Check it. 4 plus 4 is 8, plus 4 is 12, plus 2 is 14. I need groups of 3 because I'm taking the cube root. So those are going to come out. There's a group of b to the 4th, so that's going to come out, and the b squared stays inside. And there's your answer. So, you know, just kind of take your time, be careful. And when you're typing it into MyMathLab, just make sure you've got that cube root rather than a square root, or the 4th root rather than the square root. So just kind of be aware of that. All right, let's go back to multiplying, and we're going to put these 2 ideas together. We're going to multiply and look for groups of 2 or 3 or 4. All right. Now here, again, you multiply these together. I don't actually use my calculator. I leave them separate because you're going to have to look, you're going to factor it anyways. So just leave them separate and then break them down, looking for groups of 2. So let's kind of back up again. These both have an index of 2, so you can multiply their radicands together. And then once you've done that, we're going to break them apart and look for 2 of something. Since it's a square root, And it looks like these are going to come out. The 5 and the 2 stay as 10. So it's really just the two ideas put together. You multiply, look for groups, and simplify. But let's go ahead. And there's your answer. Let's look at another one. Let's look at this one right here. Now, I have a number on the outside. I have a 3. Well, whenever you have numbers on the outsides, you multiply numbers on the outside with numbers on the outside. And in this one right here, it's just a 1 on the outside. So 3 times 1 is 3. And then you've got the cube root of 25 times 5. Keep breaking them down. We're looking for 3 of something. Well, it looks like we have 3 5s. Now, what I'm going to do is those 3 5s are going to come out. And whenever they come out, they multiply with what's already out there. So these are going to come out because I have 3 of them, and they will multiply with what's already out there. So the answer is 15. So they'll come out and multiply with what's already out there. And there's nothing left in the cube root, so it's gone. The cube root is gone. So if you do bring something out, just multiply it to what's already out there. Okay, let's look at some division here. Now, this right here, do not start reducing that square root of 80. Okay, what you need to do is go backwards from that definition. Whenever I'm giving them separate, put them over the same radical, okay, the same square root. See if you can reduce it, and then go back and go from there. So always reduce your fractions. I can reduce these because they're both inside of a radical, so they would reduce. If I have numbers on the outside, they can reduce with each other. So what's outside can reduce, and what's inside can reduce. So this gives me the square root. Let's see, 5 goes into here once. 5 goes into here 16 times. So I end up with the square root of 16 over the square root of 1, which is just 1. So that was a lot easier than trying to mess with that 80. So here, the answer is 4. The principal square root of the square root of 16 is 4. So reduce them, and then take the square root or look for 2 of something. All right, let's look at this next one. I've got these 2 in the radicand. This 2 is outside, so we'll just kind of leave it there. Now, can I reduce? I'll put a 1/2. I'll just put a 1 up there with this one. So 1/2, I've got 72xy over 2. The 72 and the 2 will reduce. And we come up with 36. XY. So this goes into here once, that goes into here 36 times. If it's over 1, square root of 1 is 1, so it cancels, it just disappears. So let's see, I've got the square root of 36. So I'm hoping this doesn't really confuse you. You could write this as this right here over 2. You know what I mean? 1/2 is the same as dividing by 2. Either way. But anyways, the square root of 36 is 6. It's going to come out. So I'll have 6, and the xy's are going to stay inside. So this comes out, and those 2 stay inside, and I have this 2 underneath. Well, the 6 and the 2 can reduce. Since the 6 came out, it can reduce with what's out, okay, with what's out here. And so you end up with 3 square roots of xy. Now the xy had to stay inside because there was only 1 of each. Okay. So again, I'm kind of got over here in the other problems way, but go ahead and reduce in the radicals. Okay, that left me with 36 square root xy, and that 2 is underneath, whether or not you write it as 1/2 or the 2 underneath. Then the square root of 36 was 6. It came out and reduced with the 2 underneath and left you with a 3. And just a 1 underneath. Have a 1. Okay, let's try another one. Here, cube root, reduce these two. So this is 5, 32 over 2, the cube root. Reduce these. That gives you 16. Okay, which means I have 5 cube roots of 16. Now let's look for 3 of something in the 16. So again, since the indexes were the same, you can reduce these radicands. Okay, so it gives us 4 times 4, 2 times 2, 2 times 2. I'm looking for 3 of anything, so those are going to come out. And whatever comes out, you multiply it to what's already out there. So this becomes 10 cube roots, and that 2 will stay. And there's your answer. Now, the reason I multiplied this is because the 5 was in the numerator. This last one, the 2 was in the denominator, so it was more of a division type problem with whatever came out. All right, let's do our last one here before we look at rationalizing the denominator, which I hope won't be too bad. I know that this is long, but this is also 2 lessons. So this ended up being a little bit longer. Okay, let's go ahead and put them all underneath the 4th root, and let's reduce. So a lot of this is it's a good review of some of the stuff that we did in chapters 3. All right, 3 goes into there once, 3 goes into there 6. Okay, the B's. Okay, there's no other A's, so is that a step? Is that an what did I put a B? That A to the 9th. That's a weird name. Okay, A to the 9th. There are no other A's underneath. So that A to the 9th is going to stay, but B to the 5th, B to the 1st. Remember, you subtract exponents. There you go. So now I've got the 4th root of 6, A to the 9th, B to the 4th. And I need to look for 4 of something. Well, the 6, there's only 1, 2, and 1, 3. It stays. Excuse me. Now the 9, I can do the 9 divided by 4. So let's do that. Well, here, we'll put our answer over here. I know that the 6 has to stay. So let's do our 9 divided by 4. It goes twice with the remainder of 1. So that's an 8 with the remainder of 1, which means I have 4 groups of A squared. And then I have an A to the 1st. Okay, so when we count these, we have 2, 4, 6, 8. Could you add these together? 2 plus 2 is 4, plus 2 is 6, plus 2 is 8, plus 1 more is 9. I'm looking for groups of 4. I have 4 of those. They're going to come out. But that one's going to stay, A to the 1st. Okay, B to the 4th. This is our next one, or B to the 4th. Well, I have 4 B's, and I need 4, so they're all going to come out with none left over. Okay, and again, 4 divided by 4, 4 divided by 4 is 1. And so you've got B to the 1st times B to the 1st times B to the 1st. and no remainder. And so there you go. Kind of erase this. If you needed to, you could have absolute values around the b. You don't need the absolute values around the a squared because it's even. Only if it comes out and it's odd. Okay. That's it for reducing. You know, it just takes a lot of practice. Unfortunately, you guys, we're not done with this section yet. We're going to rationalize the denominator. And then we'll be done with this, and I'll open up these two sections. And I'm trying to kind of shorten some of the assignments. And if you need more practice, you can just do view an example. Not, you know, not necessarily view an example, but, you know, try another one there. They have that option where you can try a sample problem. Okay, we're going to rationalize the denominator. So in mathematics, they don't like to have a radical in the denominator. So we're going to get rid of that. Again, you go through the process of seeing, can I reduce the 7 and the 3? And if you can't, to rationalize the denominator, you separate these like this, okay? And you look, and again, you know, you can't, there's not 2 of anything, so we're gonna kind of leave those. I need 2 of the 3s. Why do I know I need 2? Because that's the index that we're dealing with. It's a 2. So I'm going to multiply by the number 1. That's my number 1. You can multiply anything by the number 1 and not change its value. So this comes out to be the square root of 21. I'll just leave them separate. I'm going to multiply the radicands. And this comes out to be 3 times 3. And again, if you have 2 of something, it comes out. So you come up with the square root of 21. There's not 2 of anything, they stay. I have 2 3s. So it comes out as a 3 and nothing's left over. So and now, you know, it has the same value. It's just been rationalized. There is only this 1 3 underneath, not a square root of 3. If that had been as 5, multiplied by the square root of 5. If this had been an 11, multiplied by the square root of 11 over the square root of 11. So we're matching. They're going to match here. Okay, let's try another one. Again, 5 and 16 do not reduce, and I'm looking for 3 of something. So we're going to separate them since the 5 and the 16 did not reduce. Okay. I'm going to go ahead and reduce the cube root of 16. I'm going to take out anything, you know, I need 3 of something. Well, you could also reason through it. Looking at that right now, you see this is 4 times 4. And if I wanted to rationalize that, I need 1 more 4. Okay, I need 1 more 4 here. And in order to do that, I'm going to multiply by the cube root of 4. And we'll go through this in other ways too, in case you didn't see that. I needed 3 of something. I already had 2 4s. So I'm going to multiply by another 4 cube root. So then I end up with, multiplying across, I end up with the cube root of 5 times 4, because they have cube roots, so I multiply the radicands. 4 times the new 4. Okay. And I have 3 4s. And those all come out as a 4. Now, can you multiply that 20, or do you have 3 of something inside these? This is 2 2s. So then they have to stay. There's not 3 of anything. And here's a question, can you reduce the 4 and the 20? And the answer is no, because this is inside of a radical and this is outside, so you cannot. Outside to outside, yes. Inside to inside, yes, if possible. So there's your answer. What though if you didn't realize you already had 2 4s and you just needed to introduce one more? See, like here I had a 3, being a square root, I just needed one more to make 2. I needed 3 of something here. But what if you didn't realize that? What could you have done? Well, looking at this another way, sorry, this is taking, you guys can kind of stop it at different points. Let's look at this cube root of 16 and let's go ahead and reduce it. Okay, we're going to reduce it. So we didn't realize that there was already 2 4s and we only needed one more. Okay, here, let's say I'd said, okay, this is 8 times 2. Okay, this is 2 times 4. 2 times 2. Okay, so I'm going to reduce it first before I even start. This comes out to be, let's see, I need, I broke those down, I need 3, so I'm going to take those out, cube root, and that 2 is going to stay. Okay. So now what I need to do is rationalize. This 2 is fine, but I need 3 of something. I've got 1 2, I need 2 more 2s. Because then I'll have 1 2 3. So, and then here, this right here is going to be 20. There's not 3 of anything. This right here, I've got my 3 3s now, because this is 2. The 2 came here, cube root 2 times 2 times 2. So I end up with a 2 coming out, and you multiply it to what's already out there. So you got the same answer. Okay. So when you rationalize, you're introducing numerator and denominator so that you have the right number of terms to pull them out. Here on the first one, I only needed 1 more 3 because it was a square root and I was only interested in, I needed 2 of something. Here I needed 3 of something, so I introduced a cube root of 4. Just as long as you do it in both numerator and denominator, you're fine. Okay, let's look at another one here. Cannot reduce, so this is the square root of 4 over the square root of 5b. Let's reduce the square root of 4. Can't reduce this. But I need to rationalize the denominator. I want to get rid of that radical. So I need 2 of something. I've got 1 5 and I have 1 b. I need 2. So I'm going to introduce 5 and a b. Okay. Now I'll have 2 of these and I'll have 2 of these. If you introduce it here, you're going to introduce it in the numerator. You have to do that. So multiplying across, I end up with 2 square roots of 5b over the square root. I've got 5b times 5b. So that means I have 2 5s, they come out, 2 b's, they come out. So it's 2 square roots of 5b over 5b. You cannot reduce these. One's in a radical, one's not. So there's your answer. Okay, perfect. Let's try another one, you guys. 2 more. And are we done? Yeah, we'll be done. You guys are probably think, wow. Well, if you've made it through this marathon, you're doing great. Here we go. Again, there's not, it looks a little different. It's just that this one right here started right here. Okay, they just started the same. So what we're going to do is we have a 10, okay, and it's a square root. So I need to introduce another one. I'm going to write this bigger. Okay, I need another 10 because I need 2 of them, and I need another x. So I have 2 10s and 2 x's. I needed 2 of everything. And you have to do the same thing in the numerator to rationalize it, to get rid of the radical in the denominator. So then I'm going to have 3 square roots of 10x. I'll have 2 10s, comes out, 2 x's, they come out. Now you could see, always check to see, can the 3 and this 10 reduce? And they can't. Okay. Is there 2 of anything in a 10? No, there's only 1 5 and 1 2. So here's your answer. Yay! Let's try last one. Okay. Can 7 and 32 reduce? No. So let's separate them out. All right. Because we can reduce this, the 32a squared. The b is can't, but you know, we can reduce. There's 2 of something in 32. So I'm going to go ahead and break it down until I can find 2 of something and start pulling them out. 32 is 8 times 4. 2 times 4. Okay, you can stop there because I now have 2 4s. Okay, so these are going to come out. I have 2 4s. So I'm going to have the square root of 7. 4 is going to come out. And this 2 is going to stay inside. Now, if you broke these down instead, these come out and these come out. So if you have a 2 come out and another 2 come out, you multiply them and you end up with a 4. So you can go further or just stop at the 4. Either way, you're going to get a 4. Just remember that what comes out, you multiply together. Now the a squared, the square root of a squared is a. So that comes out. So I'm just left with a b inside. So again, with that a squared, you're looking for 2 of something, and I had 2 a's, a and a. A times a is a squared. So they come out as an a. Okay, now let's rationalize it. Square root. So I need 2b, I need 2 of the 2's, and I need 2 of the b's, and I've only got 1. So I'll multiply by 2b. That leaves me with the square root of 14b. I'll just leave it, only 1 7 and 1 2. And this right here, you're going to have a 4a, which comes from here. This right here is the square root of 2b times 2b. I have 2 of those. I have 2 2's. And I have 2 b's. And they come out. And you multiply whatever comes out to whatever was out in front. So whatever comes out, you multiply it. So you get 8ab. All right. Wow, we're done. That's section 10.3 and 10.4, and it was a long one. I'm sorry, but you know, if you're having trouble with these, please let me know. I went through a lot of information pretty quickly. Again, pay attention to the index. You know, are you looking for 3 of something? And you know, and again, like if you're rationalizing the cube root, just remember I'm looking for 3 of something, and if I've already got 2, you only need to get 1 more. You only need to multiply by 1 more. Otherwise, with square roots, you've got 1 5 underneath and a b, so I needed 1 more. Okay, so I multiplied, I had 1 of each, so I needed another 1, because you need 2 underneath those radicals. So Okay. Wow. Rationalize the denominator. We did a lot. Again, I'll open up the homework assignment, and I encourage you to please text me. I'd love to meet with you guys out on Zoom, and we can go through things slower, but good luck. Keep up with the homework. We're almost done. One more chapter after this, guys. Okay. Well, have a great time.